Welcome to my YouTube channel. Today, we'll be treating compound interest. That topic sounds familiar. If you remember, on this YouTube channel, we've been able to treat simple interest. So this time around, it is compound interest. And we can calculate compound interest in two different ways, but we're still going to get the same answer. We're going to do that in this class. We can use a compound interest formula, which is on the screen. As you can see, we have it on the screen. Principal, open bracket, 1 plus rate, all raised to power time minus our principal. By implication, it means compound interest equals P into 1 plus R raised to power T minus P, where our P is the principal, our R is the rate, our T is the time. Our principal is usually in monetary form because we are dealing with money, and our rate in percentage and our time in years. We can use this formula to calculate our compound interest. So also, we can also calculate compound interest on yearly basis by using our simple interest formula. I'm sure we still remember our simple interest formula: principal times rate times time over 100. You can use it to calculate our compound interest as well, but that one will be on yearly basis. So we're going to use these two methods. And the question we have down here, and at the end of the day, you realize that we get the same result. So the reason why we're using these two methods is so that you can know how and when it suits you to use any of the two methods. So we'll start with the first method by using compound interest formula. The question is this: Edward got a loan of 1,500 naira, I'm using naira in this case, from a bank at a compound interest rate of 4% per annum. How much interest will he be paying after 6 years? How much interest will he be paying after 6 years? So let's use formula method first. So let's get our formula straight down. This is our formula. Awesome. We want to use our first method, which is our formula method. This is our formula. So compound interest equals P, open bracket, 1 plus R, all raised to power T minus P, where our P is our principal and our R is our rate, when our T is our time. So let's get our parameters. What are those things that were given? So let's get out our parameter. Awesome. So we're given our principal, which is our P, to be what? 1,500 naira. Then the next thing, we're giving our rate at 4%. Our rate at what? 4%. Awesome. Let's try and see. These are principal. Good. So now let's come down here. Our rate is what? 4%. That's 4%. And don't forget, if you are converting percent, it's still the same thing as saying 4 divided by 100. Okay, let's put that so that for record purpose, you know that 4% is still the same thing as 4 over 100. For record purpose, our 4% is still the same thing as 4 over 100. That will give us what? 0.04. Awesome. So that's our rate. Then our time. We're told our time this time around, that's 6 years. 6 years. Awesome. So with this, let's just apply straight into our formula. Great. So let's just deal with this so we can have enough space. Awesome. So our principal is 1,500. Open bracket 1. Our rate, we've been able to convert our rate because it's 4%. That's 0.04. Great. Time, that's the number of years. How many do we have here? That's 6 years. That's 6. You're actually calculating compound the interest. So I'm going to explain something for us at the end of this. So our principal here is 1,500. We are calculating the interest that will be gathered at the end of 6 years. Awesome. Having done that, so you say 1 plus 0.04 give us 1.04. 1.04 raised to power 6 minus 1,500. Great. So that means we are going to look for 1.04 raised to power 6. That will give us 1.265. If you point your calculator, 1.04 raised to power 6 will give us 1.265. So let's move to the next page. Let's just make use of this as a template. So we can do away with this. Great. We can now say equal 1,500, open brackets, 1.04 raised to power 6 give us 1.265. 1.265. Awesome. That means we are done with this. So great. So all we just need to do now is to multiply 1.265 times 1,500. So if you bring out our calculator, we punch 1,500 multiplied by 1.265. It's going to give us 1897.5. 1897.5. So because we are actually looking for the interest that will be accumulated after 6 years, so all we just need to do is to subtract this and this. So if you are doing that, so you bring out your calculator and subtract this from this, you are going to get 397.5. 397.5. Awesome. So this will be our interest. Don't forget, it's actually in naira. But I want you to take note that Edward is not paying only the interest. Remember, he got a loan of 1,500 naira. So this is the accumulated interest, the compound interest after 6 years. So that means he's paying the principal inclusive. So this is the interest that has been accumulated. If the question says, like this question we are treating, the question is asking us that how much interest will he be paying after 6 years? So this will be the answer. That's the interest is going to pay. Plus the principal inclusive, we should not forget. So if we are to add the principal, it's going to be, so this is the interest, this is the compound interest that Edward is going to pay after 6 years. That's the compound interest. But if you are calculating the compound interest plus the principal inclusive, because Edward is not only going to pay the interest alone, he's going to pay both the interest and the principal. The compound interest after 6 years. This is the compound interest after 6 years. Awesome. So, but if Edward is going, the money Edward is going to pay overall is now going to be this that we have here. This one, the interest and the principal is inclusive. So let me say the principal plus the interest that Edward is going to pay at the end of the day, the principal plus the interest, depending on what the question is asking from you. So that's the method. Awesome. So, well, you can still approximate this. Depend on what you actually want. You can still approximate this to be 1898. It's still the same thing. I still say is 1898. You're approximating depending on how your answer look like or you want it. So if this is the interest after 6 years, but cumulatively the interest and the principal that Edward is going to pay. So let's quickly go through the second method. This one is a little bit longer, but for the benefit of this class, let's just learn it. So let's say the second method. Using the same question anyway, the second method. So the second method, we are going to be calculating it year by year using our simple interest formula, using this. Year by year, year 1, year 2, year 3, year 4, up to 6. So depending on what the question asks you to do. So now, we still remember this formula. Simple interest is principal times rate times time. Now, this time around, we'll start because we are asked to calculate the compound interest for 6 years. And don't forget, we've been able to get the compound interest for 6 years inclusive with the principal. But let's use this second method and see how far we can go. Now, don't forget our principal. Okay, let me bring down this as a template. Don't forget that our principal is 1,500. Awesome. Our rate is what? That's 4%. Then our time is 6 years. Don't forget. Awesome. So what we want to prove is after using this second method, we will still get the same result. So let's move. So we now say for the first year, I want you to pay attention to this method. For the first year now, you bring out your simple interest formula. For the first year, this is your principal. For the first year, don't forget. So for the first year, your principal is 1,500. Your rate, that's your R, is 4. The time is 6. So if you bring out your calculator and punch 1,500, sorry, you need to take note because we are not using the same method as that of simple interest. This time around, we are calculating compound interest. Because it is 6 years, we are calculating our interest on yearly basis. Don't make that mistake. On yearly basis, that means we are not using 6 years straight. We'll be using it one year because we are calculating it on yearly basis. So with this, if you bring out a calculator, 1,500 times 4 times 1 divided by 100, it's going to give you 60 naira. That means the first year, the interest accumulated is 60 naira because we are calculating, don't forget, on yearly basis. The interest, because it is a compound interest for 6 years, so for the first year, 60 naira is the interest accumulated. So we move straight to the second year. This time around, before we do that, we now say, now the principal for the first year will now be the 1,500, the principal. You now add your interest for the first year to it. That's the method. You add your interest for the first year to it. So let me get this. Awesome. 60. So that will be your principal for the first year. 1,500 naira plus 60 will give us 1,560. 1,560. So that's our principal for the first year. So we'll move straight to the second year. So we'll be using this as a template. We'll be using it as a template because we're actually going to 6 years. We are going to 6 years. Awesome. Now, we change this to second year. Just follow the step. It is very easy. For the second year now, we are now going to be making use of this principal after adding our interest to it. So our principal for the second year will be 1,560. 1,560. We are going to 6 years, but because we are calculating it on yearly basis, we'll be using 1 in our time. So this time around, our principal has changed to 1,560. So if you bring out your calculator and punch 1560 times 4 times 1 divided by 100, it's going to give you 62.4. That's the interest accumulated at the second year, 62.4 naira. So this time around, you add your interest to your principal. So the principal at the end of second year will now be 1560 plus the new interest 62.4. Awesome. It's now going to give you what? 1622.4. 1622.4. 1622.4. Awesome. So we'll move straight to the third year. Let's use this as a template. We move to the third year. To the third year. This time around, our principal will now be the new principal, 1622.4. 1622.4. Awesome. For our third year. So we change this to 1622.4. 1622.4. That's our new principal. Times 4 times 1 divided by 100. So if you bring out your calculator and punch 1622.4 times 4 times 1 divided by 100, it's going to give us 64.9. 64.9. 64.9. Awesome. Now, this our principal. We'll now add it to our new interest. 1622.4 will be here. 1622.4. We'll now add it to our new interest, 64.9. 64.9. Awesome. So if you bring out your calculator and punch 1622.4 plus 64.9 is going to give us 1687.3. 1687.3. So let's do that. 1687.3. Awesome. That's our principal at the end of the third year. Very good. So we're getting closer. We move to the fourth year now. Awesome. So the fourth year. Fourth year. This time around, our new principal will be 1687.3. 1687.3. 1687.3. Don't forget to change the year as well, but when we get there, we change it to 1687.3. Our new principal. Don't forget 1687.3. Awesome. 1687.3. You bring that to your calculator and punch 1687.3 times 4 times 1 divided by 100. What is it going to give you? 1687.3 times 4 times 1 divided by 100 give us 67.5. 67.5. Awesome. So don't forget our principal that we have here, 1687.3. We add it to our new interest, 1687.3. We add it to our new interest, which is 67.5. 67.5. So if you bring out your calculator, you get your new principal for the 5th year, 1687.3 plus 67.5 is going to give you 1754.8. 1754.8. 1754.8. Awesome. So that's our new principal for the 4th year. We are getting closer. So we get this as a template for the 5th year. Great. So our new principal will now be 1754.8. 1754.8. 1754.8. Awesome. Our new principal this time around is our 5th year. Don't forget, we are through with 4. Now is our 5th year. Don't forget to change this because we are using it as a template. That's our 5th year. 1754.8. 1754.8. Awesome. Your rate and time will still remain because you are calculating it on a yearly basis. Don't forget. So if you bring out your calculator for the 5th year, 1754.8 times 4 times 1 divided by 100 will give you 70.2. 70.2. Awesome. So your principal that is here, 1754.8. Don't forget. 1754.8. 1754.8 plus your new interest, 70.2. 70.2.2. Awesome. So if you bring that to your calculator and say 1754.8 plus 70.2. 1754.8 plus 70.2 will give you 1852. 1852. 1852. 1852. Awesome. So that's our 5th year. Then the last year now, because it's just for 6 years. So let's get this as a template. For the 6th year. Awesome. So 1852. 18 is 1825, not 52. 1825. 1825. Let's correct this. 1825. Thank you very much. So our new principal will be 1825. 1825. 1825. Awesome. So our new principal here will be 1825. 1825. Great. 1825 times 4 times 1 divided by 100 will give us 73. Great. So our new principal will now be 1825 here. 1825 plus our new interest, which is 73. Awesome. If you add 1825 plus 73 to give you 1898. 1898. So 1898. Awesome. So you can see at the end of the 6th year, we've been able to get the accumulated, that is the compound interest, which is 1898. Let's check with our first method. Is it the accumulated interest and the principal? Are they the same? Great, this is it. 1898. Using the compound interest formula. But if you want to calculate it year by year, you're still able to get. Okay, let's check from the first year to the second year. Awesome. To the third. Awesome. To the fourth, fifth, and sixth. Great. So we're still able to get the same result. So if you are to calculate only the interest, you need to take caution. All you just need to do is to subtract this 1898 from the main principal, the loan that Edward got, which is 1,500. You still get only your interest, which is 396 that we got. Only the interest, don't forget, if you check here, only the interest, this is it. If you approximate this, you still get 396. 398, sorry, 398. 398, only the interest. But don't forget, Edward will not pay only the interest. He will pay it in addition to the principal, which is 1,500 naira he got. So if you add it together, you get what you have here. So this is the first method. This is the second method. Let me sound a note of warning. The reason why it is advisable for you to know the formula method is because if you are getting a loan for, say, you are paying back for 25 years, are you going to be calculating it first year, second year, third year? So it's advisable you use your formula. So the reason why we use this second method is for you to know that you can also calculate it year by year and still get the same result. You can always pause and rewind this video for clarification and understanding. Don't forget to subscribe to this YouTube channel, My Simple Maths, and press the notification bell to always get notification from us whenever we post a new video. You can always like, share any of our videos. Thank you.